Hello class 10. Today we'll continue chapter sound, and in sound today we will discuss about damped vibration and forced vibration. So damped vibrations. The periodic vibration of a body of decreasing amplitude in presence of resistive force are called the damped vibrations. So this is the definition of damped vibration. Here, as you know, in last class which we have discussed, there was only one vibration, that is restoring force was only working in natural vibration. But in damped vibration, here two forces are working. One is the restoring force and the second one is the resistive force or frictional force, which opposes the body to do its work. Hence, a body stops after doing work. The frictional force at any instant is proportional to the velocity of the body, and it has the tendency to resist the motion. As a result, the energy of the vibrating body continuously dissipates in doing work against the force of friction, and so its amplitude gradually decreases. After some time, when it has a lot of energy, it stops vibrating. The energy lost by the vibrating body changes continuously into the heat energy, and it gets dissipated in surrounding medium. Okay, the rate at which the energy is lost to the surrounding depends on the nature. Two things it depends, that is the nature of the medium, and the second one is the shape and size of the medium. Nature of the medium, that is viscosity and density, and the second one is the shape and size of the vibrating body. It also depends on the. So this is a displacement time graph. You can see how the amplitude decreases after resistive force applied. Now, few examples are there. The tuning fork one. A tuning fork, when stroked on a rubber pad, executes the damped vibration in air. See, after certain time, when the resistive force is more, the tuning fork stops vibrating. The next example is example of a simple pendulum. See, in simple pendulum, it oscillates in air or any other medium, executes the damped vibration. In first case, when we were discussing about natural vibrations, what happened when we have given a force, that is restoring force was there, and the pendulum starts vibrating and endless vibration was there. In this case, after certain time, because of this resistive force is there, the second force is the resistive force is there, and because of this resistive force, the pendulum stops its vibration after certain time, because it is applying its force to overcome the resistance. Hence, it stops, and that's why the amplitude decreases and it becomes zero. So here this is how it becomes an example of a damped vibration. Now we will discuss the difference between natural vibrations and damped vibration. Very first point, that is the amplitude of natural vibrations remains constant and the vibrations continue forever because there is no opposing force over there. In damped vibrations, the amplitude of damped vibration gradually decreases and stops. With time, first it decreases and ultimately the vibration ceases. The second point says that there is no loss of energy in natural vibrations. But in case of damped vibration, in each vibration there is some loss of energy, and hence the graph of the damped vibration amplitude gradually decreases. No external force acts on the vibrating body. The vibrations are only under the restoring force. This is the third point of natural vibrations. But in case of damped vibrations, in addition to the restoring force, a frictional force or damping force acts on the body to oppose its motion, which is only responsible for the body to reduce its amplitude. Now the last point, it says that the frequency of vibrations depends on the size and shape of the body and it remains constant. But in case of the damped vibrations, the frequency of vibration is less than the natural frequency. The decrease in frequency depends on the damping force. So these are the four differences between natural vibrations and forced vibrations. Learn it. Now we will go to the next topic, that is forced vibration. So the vibration of a body which takes place under the influence of an external periodic force acting on it are called force vibrations. Here the third force entered, and that is the external periodic force, which is responsible for the forced vibration. After every certain interval of time, it applies force, and hence it overcomes the resistive force, and the body starts its motion in a continuous process. So this is called force vibrations. So the three forces acted here, and that is, the very first is the restoring force, which was there in natural vibrations also, damped vibrations also, and here also. The very first is the restoring force. The second force is the frictional force or the opposing force, the resistive force, which was there in damped vibrations. Because of that, the vibrations stop after certain interval of time. Now here comes the third force which is there, and that is called the external periodic force. When an external periodic force is applied on a vibrating body, the body no longer vibrates with its own natural frequency, but it gradually acquires the frequency of the applied periodic force. The external applied force is called the driving force also. The amplitude of the forced vibration depends on here the frequency of the external force. If the frequency of the external force is different from the natural frequency of the body, the amplitude of oscillations is very small, which die. But if the external force is exactly equal to the natural frequency of the vibrating body, the amplitude of oscillation is very large. In absence of this damping force, the amplitude of vibration at resonance is infinite. Now we will discuss few examples. So in the example, suppose when there is a periodic external force applied, what happened when the boy was swinging? After a certain time, there is a resistive force which just stop its motion. So when an external periodic force applied by his friend, there is a proper motion, and that vibration is called force vibration. Now moving on to the next example, suppose there is in a guitar, when an artist play on its string by his fingers, the vibration in them causes the forced vibration in the air enclosed in its hollow box. Now the difference between natural vibrations and forced vibration. Before this, we discussed the difference between natural and damped vibration. Here the difference between natural and forced vibration. First point, the natural vibrations of a body in the absence of any resistive force or external force is called natural vibration. The vibrations of a body in a medium in presence of external periodic force is called forced vibration. Now the second point says the frequency of vibrations depend on the shape and size of the body. But in case of natural vibration, the frequency of the vibration is equal to the frequency of the applied force. Third point says that the frequency of vibrations remains constant in natural vibrations, but in the frequency of vibrations changes with the change in frequency of the applied force in case of forced vibration. And the last point is related to the amplitude of vibrations remains constant with time, as you have seen in the graph of the amplitude and time. But in case of forced vibration, the amplitude of the vibrations depends upon the frequency of the applied force, that is the external force. So this is the difference between natural and forced vibrations. Now we will do few questions of this exercise 7b. In this is question number 15, and you can see this diagram, that is a diagram of a displacement time graph. In the very first question, they are asking name the kind of vibrations. So this is a damped vibration. Second question, they are asking that give one example of such a vibration. Any example you can give. So when a slim branch of a tree is pulled and then released, it makes a damped vibration because it stops. Now in the third question, they are asking why is the amplitude of vibration gradually decreases. The amplitude of vibrations gradually decreases due to the frictional or the resistive force which is surrounded in the medium exerts on the body of the vibrating body. As a result, the vibrating body continuously loses its energy in doing work against the frictional force. Here what happened, the body is applying all its resistive force, all its force to overcome the resistive force. Now in the next question, last question, they are asking what happens to the vibrations of the body after some times. After some time, the vibrating body loses all its energy and stop vibrating. As you can see in the diagram, it stops after some time. Now question number 16 also I will take, and in that they are asking a tuning fork is vibrating in air. State whether the vibrations are natural or damped. Of course, in air it is a damped vibration. For natural, we need only vacuum. So till here we will discuss in this video. Next, resonance we will discuss in the next video. Okay.